Ho, 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 Merry Hackmas. This is day 23 of the Advent of Cyber 2023 Challenge. Coerced Authentication. Red challenge today. It looks like we're going to be doing a little bit of hacking, cracking. Let's get into it. Relay all the way. McSkitty is unable to authenticate to her server. It seems that McGritty has struck again and changed the password. We know it's him since Log McBlue confirmed in the logs that there were authentication attempts from his laptop. Online brute force attacks don't seem to be working, so it's time to get creative. We know that the server has a network file share, so if we trick McGreedy, perhaps we could get him to disclose the new password to us. Let's get to work. The learning objectives today are the basics of network file shares, understanding NTLM authentication, how NTLM authentication coercion attacks work, how responder works for authentication coercion attacks, enforcing authentication coercion using LNK files. So I already have the attack machine up in the VM. Okay. In today's task, we're looking at LM authentication and how threat actors can perform authentication coercion attacks. By coercing authentication, attackers can uncover sensitive information that can be used to gain access to pretty critical stuff. So we tend to think of computers as these isolated monoliths. Um, but they're not. We often have network-based resources where these computers are talking to printers, they're talking to file share servers, they're talking to application servers that connect to databases with corporate information, or if you're in government databases and things like that. Um, and it's good to have it centralized. Otherwise, you would need a distributed architecture where, imagine if everybody had the same copy of the same file on their computer, but you needed it to be consistent. That's a hard task to do. So a lot of times things that are shared resources, collaborative, they are centralized. Um, so often you have file shares, and I'm getting the feeling we're going to be working with the file share server in this situation. Um, since files are stored at a central location, it's ease of use for everybody. Um, but administrators, it seems like administrators, they can have access controls that could be applied to employees. But an important thing to understand is administrators often have elevated access controls, so it makes their accounts targets also. Um, these file shares can land an organization in hot water with red teamers. Usually, any employee has the ability to create a new network file share. Security controls are often not applied to these shares, allowing any authenticated user to access the contents. This can cause two issues. If a threat actor gains read access, they can look to exfiltrate sensitive information. If a threat actor gains write access, they can alter information stored in the share, potentially overriding critical files or staging other attacks, as we'll see in this task. Okay. Before we perform any of these attacks, we need to understand how authentication works. All right, we talked about cover rows in Active Directory on day 11, but file shares are often used on servers and workstations connect to an Active Directory domain. This allows just like the centralization of, instead of printers and files, user permissions and access credentials and things of that nature. Kerberos authentication can be used to access these file shares. However, we'll be focusing on other popular authentication protocols, NET, LTLM, or LTLM authentication. Before we dive into it, we're going to talk about SMB. It allows clients to communicate with a server like a file share. Serves for server message block. SMB governs everything from interconnecting file shares to remote administration, even the out of paper alert your computer receives when you try to print. It's the work of SMB. However, the security of earlier versions of SMB was insufficient. There's newer versions of SMB. You don't want to be using SMB version 1 for sure. For sure. Yeah, that's a real nasty one. A lot of ransomware tied to double postor and things like that. Associated with outdated SMB. Although the vulnerabilities were resolved in newer versions, legacy systems don't support them, so organizations rarely enforce them, and that's how you get the double post or eternal blue ransomware exploits. Just real nasty back in 2018, 2020. Windows authentication or LTLM authentication allows the application to play the role of a middleman between clients and Active Directory. So they have this diagram here. The application user requests access to the server. The server sends a challenge. The client sends a response. The server passes the response to the domain controller. The domain controller gives the answer to the server, which gets access granted, gets passed to the end client. So in here we have 3 devices. Similar setups also seen with things like other authentication methods like Radius, where you'll have the application user would be called like the supplicant, and then you would have the authenticator and authentication server, where you have 3 devices kind of in the play here. Since we know the user can encrypt the challenge using their password, not their actual password, but the hash derived from the password, to create a response that's sent to the server. The server then passes the challenge in response to the domain controller. Since it knows the user's password hash, it can verify the response. The response is right. The domain controller can notify the server that is successfully authenticated, and that server can provide access. This prevents the application or server from having to store the user's credential, which is now securely and exclusively stored on the domain controller. Here's the trick. If we can intercept, most likely in between here and here, if we can intercept these authentication requests and challenges, definitely in between the user and the server. If we intercept that, we can leverage them to gain unauthorized access. So let's dig a little deeper. Responding to the raise. There are usually lots of authentication challenges flying around. A popular tool to intercept them is Responder. Responder allows us to perform man-in-the-middle attacks by poisoning the responses during NTLM authentication, tricking the client into talking to you instead of the actual server. On a real land, Responder will attempt to poison any link local multicast name resolution, net BIOS name server, and web proxy auto discovery request. On large networks, these protocols allow hosts to perform their own DNS resolution for our hosts on the same local area network. So rather than overburdening the network resources like DNS servers, Windows came up with this feature to where it will try to do domain name resolution between itself and other compatible devices on the same local area network. Now, how would that work? Same way other things like ARP would work, which is broadcast. So these protocols rely heavily on broadcast. A root device running Responder will receive them. So when you broadcast a message, everything on the local area network gets it. So running Responder, you see all these messages, and then you start sending out the answers as if you're the device that you see the message is looking for. So someone's like, hey, can you tell me how to get to Harry's house? And with Responder, you would be like, yes, I'm Harry. Yeah, this is my house. Just come to me. You're not really Harry, but that's what Responder helps us to do in this situation. So there's other room about Responder. It's very popular, blah, blah, blah. During the pandemic, a lot of people started working from home and using VPNs. Now, the thing about VPNs is it reduces that broadcast domain greatly. You're not on the same local area network. Maybe virtually, but at that point it's routed and you're not in the same collision domain anymore. So it's not really viable to use it that way, but I guess we're gonna figure out a way around that limitation as well. And the way we figure it around is with the name of today's lesson, coercion. We're gonna coerce, unconventional coercion. If we can't just listen to a poison request, we have to create our own. So instead of waiting for a request, we coerce a system or service to authenticate us, allowing us to receive the challenge. Once we get this challenge based on certain conditions, we aim to perform 2 attacks. If the password of the account coerced to authenticate is weak, we can crack the corresponding challenge offline using tools like Hashcat or John D. Ripper. If the server or service's security configuration is insufficient, we can attempt to relay the challenge in order to impersonate the authenticating account. So that would be like in day 11, um, we passed the hash. Um, so option number one would be the brute force, which we did the other day. So we could brute force or pass hash. Two incredibly popular versions of coerced authentication are print spooler and petit podem. Um, Print spooler is an attack that coerces the print spooler service host to authenticate to a host of your choosing. Petit podem is similar. In these cases, it's the machine account, the actual server or computer that performs authentication. And these account passwords are random and change every 30 days. There isn't a good way for us to crack the challenge. However, often we can relay this authentication, we can pass the hash by coercing a very privileged server, such as a domain server, and then relaying the authentication attempt. A attacker could compromise not just a single server, but all of the Active Directory. So you could not only just compromise the Active Directory server, but all the users and computers that are tied into that forest, that Active Directory tree, that domain. You can rule them all. Root. Coercing the connectee. All right, we're about to get into the meat and potatoes of the task. So, in order to get to the point where we can use responder, we have to realize that we're not just going to get the traffic coming to us. We got to find a way to get the traffic coming. So, it looks like we're going to put a file on the network file share, but this file is going to be a special file that is going to have information in it to coerce authentication. So I guess if someone clicked on the file that we embedded in a file share, it would force coercion. We would see the authentication attempts, and that would be enough information to proceed further with our attack. So let's get it cracking. Wants us to CD, the roots, rooms, AOC, 23, day 23, NTLM, def. All right. And it wants us to create a LNK file. So it doesn't really go into too much detail about. I'm kind of interested more about this LNK file and what exactly it does. But we'll look into it later. Well, I'll look into it later. Let's see. So we can't. It's all about the metadata inside the file, looks like. Yeah, this is simply just creating a file for us. It's not a whole lot of interaction with this. Right. Depth G LNK dash S attacker IP. So that's 10.217.1 and F stealthy. All right. Generation complete. It's LS stealthy. Okay, so this is our file. Okay, why are you scrolling up? Stop. All right. So it looks like we're going to connect to the file share using a guest user. Put the file there. Then we're going to run responder. So let's run responder and other responder. I uh, okay. All right. CD to your stealthy man. All right. SMB client. We're gonna go share. User is guest. All right. Make greedy secret keys. Okay. Put stealthy .lnk. Okay, it's there. There. The first command. Okay, we got responder running. If you're not using the attack box, use your tunnel adapter. For the command I used to start this up. So that would be TUN, most likely TUN0 or TUN1. Oh, look, we already got some action. Okay, is my mouse just tripping or is it my virtual machine? Why is it scrolling up by itself? All right. Okay, so we already, yeah. So it wants us to get greedy keys.txt. So we're gonna get greedy keys.txt. And I guess we can exit out of here. It wants us to Okay. So it wants us to echo the hash. Copy that. Um, let's, let's echo. I'll put that in hash dot txt. All right. So we're going to use a program called John, which is what we're going to use to brute force this. Equals greedy keys.txt hash dot txt. And we got it. Greedy grabber. Greedy grabber one ampersand. No, not ampersand, at sign. So we used not interceptor. I want to say the program's called interceptor just because it's intercepting. It's responder. Um, use of the protocol that makes use of tickets, and the use of the protocol that makes use of the LTM hash. So we had Kerberos, and we have net NTLM. Yeah, Kerberos and net NTLM. All right. What is the value of the flag on the administrator's desktop? So what else do we have here? We da, da. So using the LNK files means we're not actually poisoning legitimate services, but creating new ones. So we're going to use RDP to connect to the server. So we're going to need the username and password. Copy. Let's see. RDP. RDP. Where is the RDP? We could use this or VNC viewer. Uh, all right. Is it not open? No, I don't think it's gonna open. All right. What is my password? I don't know. You tell me, guy. Mm, it's gotta be username somewhere. Username, password. Just like no. Mm, mm. Root. That's the root password. Roots. Nope. Um. Oh, look at that. Oh wow. This is the VNC viewer I tried to open like 5 minutes ago. Finally popping up like 15,000 times. Ain't that crazy? Uh, it doesn't look like this version of VNC does a RDP session anyway. So blue for you. Oh, do, do, do. So paste RDP, accept that. Administrator password is copy, paste. Okay. There's a flag on administrator's desktop. Users, administrator, desktop, flag. Copy. Ooh, that's ugly. Oh, let me just copy and paste from there to there. That's interesting. I wasn't sure how I was going to copy and paste from a remote desktop session on a Windows machine going on a virtual machine running Linux, going to whatever OS my host machine is running on, which I think I'm using Mac today. Anyway, that is all the questions. And that is day 23 of the Advent of Cyber challenge. So I'll catch you guys tomorrow, which should be the very last day. Christmas Eve's normally the last day of these things. It was really fun doing these days so far. Yeah, we'll reminisce tomorrow. Till then, be safe out here. Enjoy your Christmas weekend. Good night.